Hey everybody, how you doing? In this video, I want to talk about how to use Mathematica to supplement the calculations they did in section 3.3 in the media section in the ebook. So I'm going to jump right into Mathematica. Now, I hope that you watched the video from the ebook prior to this. So in their particular problem that they wanted is throwing a football and figuring out the maximum horizontal distance this could go. But prior to that, they wanted to talk about how the derivative affects the shape of the graph, increasing, decreasing. That's what we should be focusing on. So in order to do this, I need to compute a derivative, I need to compute some critical values, and in order to do that, well, the first thing I want to do is clear the variables. Clearing the variables helps us with any extraneous things that we may have done in the Mathematica notebook at a previous time. So I'm going to enter in the function. If you notice that the function that they gave you had a theta in it, I'm not going to use theta. I'm going to use the letter T. I can easily type it on a keyboard. And so that's why you see in my particular definition, I'm going to use T in there. Don't forget the underscore when you're defining functions. You'll also notice that in their definition, they do a v sub 0 squared. I'm not going to put a sub 0 in mine. I'm just going to put down a v instead of a v sub 0. So here's the function that I entered in. When I evaluate it, what I really want to do is take a derivative and set it equal to 0. Now I want to make a very big point here. I added this little piece of code in there. This tells me I'm going to restrict my values of t between 0 and pi over 2. So what happens if you don't do that? Well, here we go. A shift enter. That answer that we get, it's a little hard to read. But if I included that domain restriction, and I evaluated another shift enter, I get a very nice answer of pi over 4. So increasing, decreasing, I need to figure out where the derivative is positive and where the derivative is negative. I know my critical value is pi over 4. I want to draw a number line for this. I normally draw number lines to organize my thoughts. So prior to actually drawing a number line, I know I'm going to need to know the value of 0. Well, it's 0, a decimal approximation for pi over 4, and a decimal approximation for pi over 2. Probably the easiest way to do this is to use the numerical key, and I'm going to enter in pi over 4, and then pi over 2, and I'm going to close it up. When I do this, I wind up getting two answers, about 0.8 and about 1.6. I'm just rounding to one decimal place here. So I'm going to try to transfer that. Not try, I will transfer that to a first derivative line. I know my starting value is 0 and my ending value is pi over 2. That's what it said in the original problem. And I know this is about I'll write down 5.7. And then in the middle, pi over 4, this is about 0.79. Now, why are these decimal answers helpful? Because what I need to do, I need to pick a test value between 0 and pi over 4. But since I know this is 0.79, I'm going to pick a test value of 0.5. That's in between 0 and 0.79. A number between these two, I want to pick the number 1. Now, this may seem a little odd, but I'm going to make this a 1.0. And I'll show you in a minute what happens in Mathematica if I use a 1 compared to a 1.0. So what do I need to do? I need to plug those two numbers into the derivative. Well, the derivative is given by s prime. And I want to plug in 0.5, and I want to plug in 1. And notice that I did not put the 1.0 right now. So when I do this, I wind up getting these two answers. Now, what do I know about v squared? V squared is going to be positive. I'm worried about positive and negative answers here. So the first output, this 0.033 v squared, I know that's positive. So that's an easy one. But what about the second output? This second output has a cosine of 2 in it. I don't know my cosine values that well. But here's the thing. If I put a 1.0 in here, and then I evaluate it, it changes into a decimal for me. Now I see my first output is positive, and my second output, well, that's negative. So S prime of 0.5 was a positive output. S prime of 1.0 turned out to be a negative. So we know that S is increasing on the first part over here, and S is decreasing on the second part. So what does this tell us? It says that the distance that this football travels increases as we increase the angle up until pi over 4. Pi over 4, that's 45 degrees. And then the distance that the football travels starts to decrease after pi over 4. So we have an increasing to a decreasing. So this pi over 4, this produces a max distance. And this is a supplement to section 3.3 from the media section of the ebook. I hope you found this video useful. If you have any questions, send me an email. Have a great day. Bye.